this comes through correctly. But today we seem to have been stuck with some math problems, so let's see what we can do. The first problem I want is to take today's date. It's 1/30/2024. If this was a integer, I would look at it like this. 1,302,024. What I want to know about this number. I wonder what the square root of this number would be. That's too small. Let's call it x. Square root of 1,302,024. How do I go about finding that? Well, here's a little trick. You take off about, I don't know, an even number of places till you get to something you like. There's two. I don't want to deal with one, so let's take 130, I guess. It's approximately, I don't know, times 10 to the 4th, approximately. What root numbers are between are around 130? I think like 12 squared and 13 squared. 12 squared is 144. No, that's too large. 11 squared and 12 squared. 11 squared is 121. 12 squared is 144. That's 130 is around here, yeah. So that would mean that the square root, that means that x, the square root of 1,302,024 is around, say like 1.1, that's the 11 times 10 to the, what's that, like, that's 2, 10 to the second, no, hold on. It's approximately, what's that? That's 21 plus 2 zeros plus 2 more zeros, yeah. 1,100 squared plus, should give us 1,210,000. Is that right? Yeah, that's right. So that would mean that x is between $1,200. Yeah, that seems about right. That's a lot of numbers between 1,100 and 1,200. Actually, there's infinite numbers between 1,100 and 1,200, but I guess we could try to whittle it down the long way. So, let's see here. Let's try 12v. Yeah, no. Let's try 1150. I like that number better. 1150. That's 0. That's 0. That's 5. That's 25. That's 7. That's 5. And that's just ones. So 0, 5, 1, 1. And that's 1 again. 0, 5, 1, 1. Let's add this together. 0, 0, 5. That's 12. That's 12 again. That's 3. That's 1. What do we get? 322,500. I see. Where does that lie? Our number was this. No, our number was this. Let me see. $1,150 squared is 1,322,500. That's larger than x squared. So that means that the number we're looking for is between 1,100 and 1,150. We're a little closer. We knocked out about 50 integers, so let's try a little closer now. Let's try 1,125. This pen is too large. 1,125 squared, that's 5. That's 25. That's 5, that's 12. That's 6. That's 5. That's 10. That's 5. That's 2. That's 2. The rest is just 1. So that's 5, 2, 1, 1. 5, 1, 1. 5, 2, 16. 15, 6, 2, 1. Is that right? Seems approximately right. I guess being approximately right is just as good as being right, I guess. However, this number is smaller than x squared, so that means our new range is 1,125 and 1,150. We got even closer. Let's try. I'm just gonna guess. 1,100 is a new range. 1,130 squared. Well, that's a 0. That makes it easy. That's a 3 and 0. That's 9. And then 3 and 3. And then just 1, which is 0, 3, 1, 1. Then you do that again. 0, 3, 1, 1. Add all together, you get 0, 0, 9. That's 6, that's 7, that's 2, that's 1. That's 2. I hope it's legible. The number is smaller than x squared again. So the new range is 1,130 x 1,150. It's getting very close, but not close enough. New number, let's test. I don't know, 140 squared. That's 0. 16 and 5 and 4. And then just the 1, which is 0, 4, 1, 1. You do that again. Thank goodness for all the 1s. It saves me having to do a lot of math. I like math, but I'd prefer to solve my problems quickly rather than in a very, very long, drawn-out way. Okay, the new number. It's too small. Did I do my math right? This number is larger than that number. Yeah, that's right. Okay, well, I guess the new range will be between 140 and 150. 1,140x and 1,150. Only 10 integers between this and that. But infinite numbers that could be our variable x. Okay. Let's test another number. 145. We're out of the zeros, so, you know, we might have to do a bit more math than usual, but that's fine. Okay. Let's square it. It's 5, that's 2, that's 20, that's 2, that's 7, and 5. That's 20, that's 2, that's 10, that's 5, and 4. And then the ones. 5, 4, 1, 1. That's 4. 5, 4, 1, 1. Okay, that's 5, that's 2, that's 12. 15. That's 20. That's 11. That's 3 and that's 1. Really? I do my math right? This doesn't seem right. Hold on. 5 and 5. Hold on. Erase this. I'm willing to double check my math here. I want to make sure I get this correct. 1, 1, 4, 5, 1, 1, 4, 5. That's 5, that's 2. That's 22. That's 22. That's 7 and 5. There you go. These big blocky letters make it hard to write. Make the pen a little smaller. That's 20. That's 6. That's 18. 4 and 5 and 4. X out. Then you get the ones. 5, 4, 1, 1. 5, 4, 1, 1. You get 5. You get 2. That's 20. 5, 15, 19, 21. That's 8, 10, 11. That's 3 and 1. And that seems better. That number was far too close. It was 2. It wasn't large enough. It seems more accurate. It's larger than x squared, so the range is between 140 and 145. 1145. Let's see. Let's try 43. That's 9. That's 12. That's 4 and 3. That's 12. 16. That's 17. That's 5 and 4. Then the ones. I love the ones. They're very, very quick. Although, you don't get to save all the little emotions. That's 14. It's 9 plus 7, which is 16. That's 10. That's 3 and 1. 1, 3. It's too large. Too large for 1,000. I wonder if we'll find it before we run out of space on our page. Let's see. Let's try 1. I love the ones. 1, 1, 4, 1 squared. That's 1, 4, 1, 1. That's too close to the edge of the page. I can't do that. 1,141 squared. 1, 4, 1, 1. 4, 16, 4, that's 5 and 4. And then 1, 4, 1, 1. And then 1, 4, 1, 1. Then you add it to 1, that's 8, that's 8, that's 10. That's 10 again. That's 3 and that's 1. Huh. It's too small. It's not large enough number. So that's between 140, 1141 and 1143. Logically, it sounds like it should be around 2, but I guess we'll just have to see. 142, 1142. That's 4, that's 8, and 2, 2. Did this one already. This is 8. That's 16. That's 16. Hold on, let me get my... Let's get this right. That's 4, that's 16. It's at 8, 10, 11. Sorry for the messy numbers. That's 10, that's 14. That's 10 again. That's 3, that's 1. This one is too large, so that means it should be between 141 and 142. Approximately. Oh, what's this? I turned off all my alerts. BD VT. Doing some ASMR. Oh, we could do that number later. I'll keep it in mind. That's a very funny number. 80,082. I have some very favorite 6-digit numbers we could test afterwards, but keep that on the back burner. Today I'm taking today's date. If it was a number of 1,302,024, and we're trying to find the square root of that number. So I know the square root of that number is between 141 and 1,141 and 1,142. I feel like I could do more. Let me move over to the next decimal place. We'll do 1,141.5 squared. I don't know how many decimal places this will take. We just have to try. 5 times 5 is 25. And that's 7, and that's 20. And that's 7, and that's 5. Then the ones. I love doing the ones. That's 5, 1, 4, 1, 1. That was very quick. That's 20. That's 6. That's 16. That's 5. That's 4. Now the rest of this should be a little easier because it's just the number 1. Wow, look at that. Another one is 5, 4. No. 5, 1, 4, 1, 1. Add everything together. Don't move the ruler. Oh no, I changed layers. Math can only be done on the math layer. That's 5. That's 12. That's 2. Let's see here. That's 10. Plus 5. 15 plus 7 is 22. The 2 over there. That's a 12. 14 plus 6 is 20. Is that right? Let me double check that. That's 6. That's 6 again. That's 12. That's 6. That's 18 plus 2 is 20. Yeah. That's 9. That's 10. Plus 3 is 13. That's 8. That's 10. Then 3 and 1. Move 2 decimal places over. The number, just look at today's date. 1:30. It's a little, no, it's about 1,000 too large. Hey Mac, we're just doing some math ASMR. I know math can be very boring, so this is probably a good idea for an ASMR stream. Hopefully I'm coming through clearly. Doing some jigsaw. That would also make a good ASMR stream. Jigsaw ASMR. Let me see here. According to this number's too large. So our range is between 1141.5, 1141, and 1141.5. I have to move a little bit closer to the number. Maybe 2. 1141.2. Square it. What do you get? 2 times 2 is 4. That's 8. That's 2 and 2. This is the number 1. Wait a minute. I'm missing something. That's not enough digits. That's 4. That's 8. Oh, here it is. I'm missing number 1. That's 4. That's 2. 8, 2, 2. That's 2, 1, 4, 1, 1. That's 8. That's 4. That's 16. That's 5 and 4. Now the number ones. Let's move our math over. It's a little crowded. Excuse me, math. I'm gonna scooch over a little bit. Okay. What was I saying? The number 1. That's 2. That's 1, 4, 1, 1. Then you do it again. 2, 1, 4, 1, 1. You add it. That's 4, that's 4, that's 17. 8, that's 8, that's 12, that's 13. That's 6 plus, that's 10, that's 13 again. Is that right? 6 plus, that's 8, 10, 13, yeah. That's 10. Wait a minute. Yeah, that's 10 plus, that's 12. A lot of 10s. That's 10 again. 3, 1. Huh. Would you look at that? What about this number? 1, 3, 0, 2, 3, 3, 7. That's too large still. That's interesting. 1, 1, 4, 1. And 1, 1, 4, 1.2. Logic would have you believe that that would mean that the next one we should test is 114, 0.1. But we're almost out of math space. Let's do it anyway. 114, 1. I should have started with this one. I love the number 1. It's very good to multiply with. 114, 1, 1. And then 1, 1, 4, 1, 1. Then the spicy number 4 brings it to 4, 4. 16, 5, 4. Is that right? 2, 3, 4, 5, 1, 2, 3, 4, 5. Yep, that's correct. Now back to 1, 1, 4. And then I do it one last time. 1, 1, 4. There you go. 1. That's 2. That's 9. That's 10. That's 9. 10. 11. That's 11. That's 10 again. That's 12. That's 10. That's 3 and 1. Move that over. What do we get? 1, 3, 0, 2, 1. It's too large still. 1, 1, 4, 0. And 1, 1, 4.1. Is that right? What was my last range? Was 1, 1, 4, 1, 1. Where did I leave it? This is what happens when your math is all over the place. I mean, I guess. So I just need to find some more space then. Not just shrink everything. You too. Shrink this as well. There it goes. Will not be missed, but I can zoom in and check my work again if I need to. Okay, let's write 1, 1, 4. 1, 1, 4. Let's see. 1.1 is too large. And 4.0 is too small, so let's try 1.05. These decimal places are starting to get out of hand. But be persistent. 5, that's 20. That's 7, that's 5. Excuse me, math, I need some more room. space. Now the next one, 0, very easy. And then the number 1, well, hello Mr. 1, seem to be working a lot today. I need to make sure that they're properly lined up, because then my numbers will be all over the place and I won't be able to add them correctly. 1, 2, 3, 4, 1, 2, 3, 4. Okay, now 4. 4 and 5 is 20. And then 2. And then 4. And then 16. And then 5. And then 4. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. That's still correct. And now for the number 1. So now we go 5, 0. Hold on, my numbers are getting jumbled up. 5, 0, 1, 4, 1. And then I gotta do that again. 5, 0, 1, 4, 1, 1. What do you get? Okay, 5 and 2 and 10 and 1. And that's 10, that's 15. 15 and 14, that's 19. Oh, let me double check that. That's 10. That's 14 plus 5 is 19. That's 9. That's 10, that's 11. That's 10 again. That's 3 and 1. Okay, the number we have now. 1,301,301. Yeah, 301,995. This number is closer to the 19, to 95, to the 90s. Okay then. That can't be correct. It's too small. We need a larger number. Our new range is from 1141. Wait a minute. It's between 114, 1.05. And 114, 1.1. So many numbers to choose from. Which is the right one? Go from 0.5 to, I don't know, 0.7. I'm gonna need some more room. At 49, that's 4, 7, 8, 28, that's 9 and 7. Okay, see, we're back to the number 1 again. So we have 7, 0, 1, 4, 1, 1. Now for number 4, that's 8, 28, 28, 2. And then 4, wait, 1, 2, and then 16, and then 5, and then 4 again. Okay, now for the number 1 again. 7, 0, 1, 4, 1, 1. Yeah, I'm still suffering from a little bit of back pain, but that's alright. It's all over for now. 701 411. Add that up, you get 9 4 14 17. That's 10. Wait a minute. Where did my numbers get jumbled again? That's that one. Okay. This number was not like that. Wow, my numbers are getting jumbled. 10 plus 10 is 20. 20. That's 9. Plus 8 is 17. Plus 7 is 24. That's 7, 9, 10. That's 10, 12. That's 10 again, and then 3 and 1. Okay. 4 decimal places. Where are we now? Oh, what number am I looking at? Is that a 6 or is that a 0? Let's see, 6 plus 2, that's a 0. Okay, 1,302,040. This is about 20 years in the future. That can't be right. It's still too large, but it's very close. If my math is correct. Then our X should be somewhere in here. That just leaves the number 1,141.06. That's what we're gonna do. And we're gonna square it like normal. That's 6, that's 3, that's 6, that's 24, that's 8, and then that's 6. Make sure my numbers are legible. Otherwise I won't be able to add them. That looks like plenty of space, and then you got a bunch of zeros. This is some very wide math. Okay, 10, 0. Then the 1, 6, 0, 1, 4, 1, 1. That's a lot of digits. Should I do the 6s correctly? 6, 6, that's 36, that's 36, that's 6, and then that's 24, and that's 8. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. I guess I did. Whatever. Okay, 1, 2, 3, 4, 1, 2, 3, now it's 4. 6 is 24. Then move the 2 over. Then 4. And then 16. And then 5. And then 4. Now for the number 1. Let's see here. Keep it from getting jumbled. Okay. 6, 0, 1, 4, 1, 1. Okay. Just do that again. 6, 0, 1, 4, 1, 1. Add it together, you get 6 and 3 and 12 and 9 and what's that, 17 and 10, 11, 15, 21 and 8 and 10 and 10 and 15, wait, 10 and 12, 12, right? That's 12, and then 10 again, 10 again, really, 3 and 1, okay. My number is this, 1,302,000, wait a minute, 17, okay. This number's still too small. So our new range is 1141.06 in X and 1141.07. That's pretty good. We've narrowed it down to somewhere in this range, but wow, there's still more numbers to go through. We still have options. We have to go down one more decimal point again. 0.65. It's starting to get ridiculous, but oh well. Okay, we'll play keep all these numbers together. 5, 25, that's 30, plus 2 is 37. Then 3 is 0, and then 5, and then 20, and then 7, and then 5. I think that's right. 5 is 25, yep. And then no, this isn't 37. It's just 30 plus 2, 32. Then move to 3, and then 5 and 0 is 3, and then 5 and 1 is 5, and then 5 and 4 is 20. 5 and 1 is 5 plus 2 is 7, and 5 and 1 is 5 again. Okay. The next number is 6. That's 30. Okay. That's 36 plus 3 is 9. And then the 3, and then the 6, then 24. And then the 8, and then the 6 again. Okay. Now time for the 0. Favorite number. Nothing. Okay. Now for the number 1. Let's just put little X's to keep them in check. I don't want to get these numbers out of whack. Let's see, 1, 2, 3, 4. 1, 2, 3, 4. The number 1. That's good. 5, 6, 0, 1, 4, 1, 1. Okay. Okay, next numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Number 4. Okay. I'm not scared of number 4. It's just a number. 4 and 5 is 20. 4 and that's 24 plus 2 is 26. And the 0 is that's 2. And then the 4. And then the 16. And then the 5. And then the 4 again. Wow. This is getting stupidly large in terms of how much space this one problem takes up, but I guess that's just how it is. 1, 2, 3, 4, 5, 6. That's 5 X's. 2, 3, 4, 5, 6. That's the number 1. Thank goodness there's so many ones, or I would be here forever. Okay. 5, 6, 0, 1, 4, 1, 1. Add all of this up and you get 5, and 2, and 12, and 14, and 13. What number is that? What am I looking at? Is that another 7? Or is that the number 1? Oh man, okay, let's do this again. 6 and 5 is 30, and 6 and that's 9, then the 3. 6 and 1 is 6, it's 24. That's a 6. 6 is 24, that's a 4. That doesn't look like number 4. What the hell was I doing when I wrote that? Whatever. What's the next one? Oh, I suck. Is that SAT? Is that you? Are you in chat right now? Okay, let's see. Osman Mutt. That doesn't sound like SAT, but it could be an alternate profile. I don't know. What's this one? This is 12. Wait a minute. No. 5, 2, 12. That's 1. 5, 2, 12. 5, 2, 12. That's 14. Move the 14 over. That's 1. So it's 13. that's 15. 15 plus 3 is 18. 18 plus 11 is 29. 2. That's 10. 14. That's 20. That's 8. 9, 10 again. Lots of tens. That's 12. Say that's 9 and 2 and 1. But that can't be right. That number is smaller than the other number. That's impossible. I must have done my math incorrectly. 1141.065 squared has to be larger than 1041. 1141.06. That's just not possible. I must have done my math wrong somewhere. This number should be greater than that number, but it's not. Okay, let me do this again. 5, 2, 12, 14, 13, 7, that's 11, 12, plus 11. Let's put some lines in there. Not the curvy lines, the regular lines. Like, I'm doing math outside my lines. I need to keep the lines where they belong. Okay, let's try this one. Okay, that should make it a bit easier. 5, 2, that's 12. 12, that's 14. That's 13. That's 11. 12. Plus 11. 23. That's 15. 16, 17, 18. Plus 6 is 24. Plus 5 is 29. What is that? That's 10. Plus 6, 16. This number here is wrong. Right there. That was incorrect. That's 10. Plus 6 is 16. Plus 6, 22. That's 2. That's 8, 10. That's 12 again. That's 12. Carry over the 1. That's 8. That's 12. That's 13. Wait a minute. I might be carrying too many ones. Hold on. Oh, these little 2s and 1s really messing me up right now. Okay. Let's see here. That is 10 plus, that's 16, that's 22, so move the 2 over. That's 4, that's 10, that's 12, and that's the 1, that's the little 1 you carry over. That's 7, no, that's 10 plus 2, it's 12. Carry the 1 over. That's another 10. That's a 3 and 1, there you go. Is this number larger? Yes, it is. Move over 6 decimal points. Okay. This number squared brings us to 1,302,229, which is about 200 years in the future. But it seems more correct. Let's see where we are with the 7. Where did the 7 bring us? Another math mistake. This number should be large. This number should be smaller than that number. But we're gonna move on from there. Let me see here. 1, 1, 4, 1, 6, 5. Let's see here. The mistake is right here. But how? 3, 3, 4, 2, 2, 5. What did I get wrong? looks good. That's good. That's good. That's good. That's fine. That's fine. That's fine. And then here. What do I get? Okay. That's 10, 15, 16. 18. 18 plus 11. 11, right? 18 plus 11. 29. 9, bring the 2 over. That's 10. That's, 16. 22. Well, even so, this number's still too large. That means our range is 1141.06 and 1141.065. Wow. Okay, so where do I go next? Let's do point. 114.061 squared. And let me separate the numbers, they're too close. 1.061. Yeah, that's about right. 1141.061. And then you square it, let's say 160.1411. And you get 6, and then you get 6, and then 3, and then 6, and then the 24, and then the 8, and then the 6. Okay, the next part is 0. That's simple. I really wish my zeros didn't look like 6s all the time. It would be way less confusing. Then we multiply by 1. So we'll get 160, 1411. Is that right? Yep, that's right. Strangely enough, I don't think it's the multiplication, I think it's the addition that messes you up. So 4 times 1 is 4, times 6 is 24, plus 0 is 0, plus 2 is 2, and then 4, and then 16, and then 5, and then 4. I always don't need more space. They never said math had to be pretty. It just had to be right. X, 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 X. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now we're back to the 1. It's 1, 6, 0, 1, 4, 1, 1. How many more digits? 1, 2, 3, 4, 5, 6. 1, 6, 0, 1, 4. What do you get? You get 1, you get 12, you get 7, you get 5, you get 20. Make that look like a 0, not a 2. Move the 2 over. You get 7 plus 5, which is 12. You get 10. You get 18, 20 again. You get 10, 16, 22. Okay, you get 10 again. Let's see, that's 10 plus 2 is 12. That's 10, 3, 1. Move over 6 decimal places. Wow, okay. Is that a 0 or is that a 6? God damn it. That's a 0. Wow, that's really close. It's only 4 years in the past. Okay, well, So this number's too small. 114. I want to get at least one more decimal place correct. Okay, what was the last range? This number's too small, so that means it's between 0.061 and 0.07. Wow. Feels like a lot of numbers. One 141.07. I want to get at least up to the 1000th place, I suppose. But let's see. What would be the next logical step? This number's too small. Let's try 1141.06. 5. Did I do that one already? Oh, yes, I did. Let's not make the same mistake as last time. It's not 0.7. It's 0.065. That number seemed familiar. I felt like I did that number already. Okay. So between 1 and 5, I'm going to pick the number 3. So that means we do 1.063. Okay. Yeah, that's fine. Then you square it. Okay. Then you multiply. That's 9. That's 18. That's 1 and 3 and 12 and 4 and 3. Why can't I just write it correctly? It always has to look kind of crooked. Okay, that's 18. That's 37. That's 3. That's 6. It's 24. That's 8. And that's 6. And 0. 0 keeps it nice and clean, I suppose. And 1. 3. 6. 0. 1. 4. 1. 1. And 4. Running out of space, almost can't even see the numbers anymore. That's 12. That's 25. That's 2. That's 4 and 16 and 5. 16 and 5 and 4. Okay, now for the ones. 3, 6, 0, 1, 4, 1, 1. Then you do it again. 3, 6, 0. Draw it correctly. 6, 0, 1, 4, 1, 1. Is that enough? Okay, I think that's all the numbers. Let's add them up. You got 9, you got 16, you got 9 again, 9 again, you got 12, plus 4, that's 16. You got 9 plus 8, which is 17. You got 12 plus 3 is 15, plus 9 is 24. You got 10 plus 6, 16 plus 6 is 22. Okay, that's 8, that's 10. That's 10 and 12, and that is 10 again, and 3 and 1. 4 or 6 decimal places. What year is this? At least I got the right year. Wow, that's really, really close. 1,302,024. That is the exact date of today, plus several decimal places. So that means it's a little bit smaller than that number. But I'll take it. So, the square root of today being 1,000,000 Square root of that is approximately 1141.063. Okay, let me test it. Take out the calculator. Okay. Square root of that. Okay, according to this, it is 1141.06266260888. And I imagine many, many more decimal places, but we got really close up to here. That's pretty good. Let's wrinkle this down. Okay. Now that we have some more space, let's take the here. It's quite a bit smaller. I mean, that's not really how people write it. They usually write it like that without the comma. I got 80,082. Very good number. I wonder, what can I do with this number? Oh, let's square it. 80,082. It's always better when there's more of it. 2 by 2 is 4, and then that's 16, and then that's 1. And then that is 0, and then that's 16 again. And then you get 16, that's 65, and then 6, and then 0, and then 64. And then now we get to the zeros. Done. There's that zero's done. Then the 8 again. But since we already did the 8, we don't need to do it again. Let's see, 1, 2, that's this number here. 6, 5, 6, 0, 4, 6. When you get very confident in your math, you can just kind of borrow from your own work. That's 4 and 12, and 7 and 6 and 12, and 10, 11 and 13, and 1 and 4 and 6 and 1. Wait, no, that's not a 1, that's a plus. Can't even read my own handwriting. If this is right, then that would mean that 80,000 and 82 squared is what is that? 6,413,126,724. Let's check the Pokédex of math or calculator. Let's say 6,413,126,724. That's correct. Congratulations. We took this number and we squared it, so that's pretty cool. Who would have thought? Let's see, what else is there? You know, I had this idea. I was wondering, if you took every single person on Earth and made them play rock, paper, scissors, how many games would it take to beat everyone on Earth? Well, that's just math. You take 8 billion, approximately. It's probably more, but I'll just make it 8 billion. And in the first game, wait, hold on. Let's turn the paper over. Let's give it the 90-degree angle. There you go. Take 8 billion. It's 8,000. 8 million. 8 billion, which is, 8.0 times 10 to the 1, 2, 3, 4, 5, 6, 7, 10 to the 9th. So, in the first game, hey Zeke. What kind of puzzle? It's a jigsaw puzzle. I mean, I think the pieces Very boring stuff. Very good for ASMR. But anyway, missed it. If you take all 8 billion people and play rock, paper, scissors, in the very first game, 4 billion people would lose. Any ties are, of course, dealt with another game of rock, paper, scissors until there is a victor. So, in the first game, 4 billion people would lose. And in the second game, another 2 billion people would lose. Okay, that's a lot of people. Assuming you've made it this far, you've already beat about 6 billion people. In the third game, 1 billion people would lose. If you made it this far, if you have won 3 games of rock, paper, scissors, you've beaten about 7 billion people, but okay. In the fourth game, let's make some lines. In the fourth game, there would be 500 million people would lose, so 500 million people would lose the game. That would only leave 5 times 10 to the 8th. I think, yeah, that's about right. Escape jigsaw themed puzzle. I don't know what you mean. In the fifth game, 250 million people would lose. 2.5 times 10 to the 8th. The sixth game, that brings us to 1.25 times 10 to the 8th. Okay. The seventh game, all 8 billion people in a Saw situation. Who would be Jigsaw? Would Jigsaw be the 8 billionth person? Meaning only 7,999,999,999 people would be in the Saw trap, and Jigsaw himself would be the 8th billionth. Perhaps. I'd have to do the math on that to be sure, but I think that's about right. What are we? Seventh game. Let me see here. 1,250 cut in half is, 6.125 times 10 to the 7th, is that right? Let me see if I got my math right. You cut that in half. I bet 2, you get 625. Yeah, no, it's almost right. There you go. That's correct. Only one person so far. Need to get those numbers up. What about the 8th game? The 8th game we have 3.125 times 10 to the 7th. Yeah, that's right. And the 9th game we have, wow, what's that number cut in half? 31250. Cut in half, you get 1. And then the 11. The 2 little 1s, the 11. It's 5. Bring it down to 10, bring it down to 1, and then 6. 25. That brings us to 1.5625 times 10 to the 7th. Yeah, that's about right. If you've made it to the 10th game, very good, lucky you. If you made it to the 10th game, then we have 1.56250 cut in half. 7, and then 16 is 8, and then 1 and 25. We have 7.125 times 10 to the 6th. What number is that? Let's just break it down. 7, 8, 1, 2, 5, 1, 2, 3, 4. 2 more zeros. If you made it past 10 games, there's only 7,812,500 people you still have to beat. Ghost Stories. Gotta watch that. If it's very good, I suppose. Can't imagine winning this many games, but, some people are just really lucky, I guess. Okay, cut this in half. What do you get? That's 6, that's 9. That's 0 and 6, and that is 250. By the 11th game. Is that right? No, that's not right. This should be a 3. Not a 6. That didn't look right, did it? Okay. 3,906,250 people. Okay. If you cut those, what do you get left? Okay, cut as an F. You get a 1, and 19 is 9. And you carry the 1 and 10 is 5. And the 6 is 3. And that's 125. Wow. After 12 games, we finally reached an odd number. This is maths. We're doing very good maths. Well, in this situational scenario, where everyone was forced to play rock, paper, scissors, I suppose. But what's interesting is on the 12th game, very interesting, on the 12th game, we have an odd number of people. So what happens? Well, I imagine one unlucky group will have to play triples, meaning everyone else plays rock, paper, scissors, duos, but one unlucky team has to face 2 other people in order to break the odd number. That seems fair, I guess. So we cut this in half, or rather, we cut this number in half, if I could write it correctly. 1953124. That's a 9, carry the 1, that's 15. That's 7, carry the 1, that's 13 and 6. Carry the 1, that's 11 and 5. Carry the 1, that's 12 and 6 and 2. 9, 7, 6, 5, 6, 2. Wow. We're under 1 million people. It only takes 13 games and we're down to less than 1 million people from the whole population. Well, that's neat. Okay, cut this in half again. On the 14th game, we have, that's a 4, carry the 1, and that's a 17, that's 8. Carry the 1, that's 16 and 8 again, and then 5 is 2, carry the 1, 16 and 8 and 1. At the 14th game, there should be less than 500,000 people, of course. That just makes logical sense. But we have reached another odd number, so unfortunately some random group will have to play 3 trios. But we'll cut it in half anyway. 8, 0. Cut it in half, you get 2, 4, 4, 1, 4, 3. Another triples game, would you look at that? Another triples game. Wow. On the 12th game, on the 14th game, and on the 15th game, there will be triples. And yes, there will be triples. 4, 4, 1, 4, 2. Cut that in half, you have 1, 2, 2. 0, 7, 1. Yet another triples game. Wow, okay. We'll cut it in half again. You get to 6, 1, 0, 35. Wow, another triples game. We end on another odd number. Okay. The 18th game, we have 6, 1, 0, 3, 4. We cut that in half. We get 3, 0, 5. 34 is, I think, yeah. So 1, and then you get 1, 14, 7. Okay. Another odd number again. Wow. Looks like people have a good chance of ending in a triples game. Given there's so many of them. We're now at 19 games of rock, paper, scissors, so 3, 0, 5, 6 cut in half. It's 15. And it's 2, carry the 1, that's 11, that's 5, carry the 1. That's 16, 8. Okay. 1, 5, 2, 5, 8. Only 15,000 people left to beat. Good luck. Okay. 16th game, triples game. 17th game, another triples game. In the 18th game, another triples game. In the 20th game, another triples game, believe it or not. But okay. Did I get that number right? Yeah, I did. 7, 6, 2, 8. 7, 6, 2, 8. If we cut that in half, what do we get? Okay, well, 2, and that's, no, not 6. What am I thinking? That's 3. Carry the 1, that's 16. That's 18. No, that's 16. That's 8 cut in half. 1 and 4. 21 games. And there are only 3,814 people left. Cut in half again. Let's see here. That's 1 and 9 and 7. Triples game. Wow, look at that. There can't be too many games left. We've already won 22 games of rock, paper, scissors in a row. How much are left to beat? So if we cut in half, we get 19, that's 9, and then carry the 1, that's 5 and 3. Game 23, give it up for game 23. 953 people. Wow. And to think we started with whole 8 billion. Maybe we should have started higher. Okay. Triples game again. 24. Now let's just do this in my head. I don't need to write it down, I guess. That's 4, carry the 1, that's 15. That's 7, carry the 1, that's gonna be a 12, not 13, that's 6. Game 25. That's a 2, and 76 brings it down to, is that like a 3, and 60, 38, 238, yep. Game 26. That's 100 and 19. Yeah. Yeah, 119. Triples game again. Game 27. I said we're nearing the end, but that was like 10 games ago, so let me see. Back on game 17. We only had 60,000 people. That is way less than 1%, actually. Hold on, let me see. On game 17, we're at 60,000 people, which is 6.1 approximately times 10 to the 10 to the 4th, which is 1% of times 10 to the 6th, which is 1% of about 1/10 to the 8th. So by the 17th game, there is less than 1% of 1%. That's correct, yeah. Less than 1% of 1%. But by the 27th game, after this triples game, we have 5, it's 5, 1, and 18 is 959 people. Is that right? Yeah, that's right. So it would be 18, yeah. And we're left with another triples game. Game 28. 20. Wait, for real. Wait, no, that can't be right. Hold on. That's 2. Okay, the 1, that's 9. Okay. I was worried there for a sec. There's no way on game 28 that there are 28 people. I would have lost my mind. But no. Game 28, there's 29 people. I hope I didn't do my math wrong anywhere. I'm gonna double check later, but okay. Game 29. There's gonna be 14 people. It's almost there. On game 30, there's 7. On game 31, there's gonna be 3. And on game 32, you've won the game. It would take 32 consecutive wins of rock, paper, scissors in order to beat everyone on planet Earth. check. Gonna bust out the calculator. Okay. Hope it goes this high anyway. Okay, 8 million. 8 billion divided by 2. That's one game. Divided by 2. That's another game. Let me just check right here. And by 2, that's another game. Yep, we're down to 1 billion divided by 2. 500 million. By 2, 250 million divided by 2. 125 million divided by 2. 62,500,000. Yep, divided by 2. So you can see we're right here. Game number 8. 31,250,000. Okay, divided by 2. We're right here. 15,625,000. Divided by 2. 7,800,500. We're still on track. Divided by 2. That leaves us with 3,906,250. Okay, divided by 2. 953,125. Subtract 1. Divided by 2. Game 13. 976,562. Okay, pretty good. We're still on track. Divided by 2. Game 14. 488,281. Odd number minus 1. Okay. Take that number and divide it by 2. What are we at? 244,140. Yeah, that's right. Wait a minute. Multiply this by 2. Let's go back up. Yeah, okay. Oh no. Oh no. I seem to have made a mistake right here. This is not a 6. This is 0. Once again, my 6s and my 0s have confused me to no end. Meaning that game 15 would leave this now. Which means this is not an odd game. Wow. Wouldn't it be amazing if game 28 had only 28 people or 29 people? But alas, that is not true. All of this can be thrown out and started over. Goodbye. Okay, the next, now that we have this one correct, this is not an odd game. This is not a triple game, but a normal game. Got excited there for a sec, but math is just math. Okay. 244,140. Cut in half is 1,220,75. It's an odd game. Yep. And this cut in half in game 17 is going to be 6,2,0,74. Cut in half is 37. Yeah. Odd game again. 18. Game 18. What are we left with? 3, 1, 0. 36 cut in half is 18. Right? Yeah, that's right. Okay. No games yet, but who knows? I'm sure they'll come up. In our last example, it took us 32 games, but there was a slight mistake. Let's see if that makes a difference. That cut in half is 15. Carry the 1. That's 5. 18 is 09. Yep. Yeah, that's about right. So 1. 2 is 1. Carry the 1. And that's 11. 5. Carry the 1. That's 10. And 5. Carry the 1 is 0. 18 is 9. Game 20. We've reached another triple game, I suppose. This number is 7, and carry the 1 is 15, and 7 again. 1 is 10 is 5. This is 8, not 9. But it's the 4. Game 21. That's 7, okay, the 1. 14 is 7 again. Okay. Game 22. Okay, that's 1. Okay, the 1 is 18 and 9. Okay, this is triples game again. Okay, where was I? 19. Carry, there's no carrying over the 1, so that would mean that's just 7. And 7, would be 3, and that's 17. No, it's 16, which would be 8, because it's a triples game, so. Game 23. Oh, we're getting there slowly, but surely we're getting there. 19, that's a 9. Carry the 1 is 13, which brings us to 6. Okay, the 1 is 18 and 9. Triples gaming yet again. 24. That's 4. Okay, the 1 is 16. That's 8. And it's going to be an 8 because triples game minus 1, which is 4. Yeah. Yeah. Okay, game 25. That's an easy one. That's 2, 4, 2. Game 26. That would be 1, 2, 1. Game 27. 60. This is triples game too. 60. In 28. That's 30. Oh, so close. So close. Look at that. I couldn't get it. Slab Lord, how you doing? We're just doing some math. What we're doing is if we took all 8 billion people and made them play rock, paper, scissors, how many games would it take to beat everybody? Well, we're up to game 28. There's 30 people left. So game 29. Losing my marbles here. It's not 30, it's game 29. There's 15 people left. That's a triple game. Game 30. 7 people. 31. 3 people. 32. You've won the game. Wow. This is triples. This is triples. This is triples. Wow. Looks like it took the same number of games anyway. 32 games, you would have beaten all 8 billion people. Wonder how many of these games were triples games. Let's see here. Game 12 is the first game where 3 people would have to play each other in order to break into an even number. Let me see. Game 12. And game 14 as well. And game 14. And game 16. And game 17. And game 19 as well. Game 21. It seems to skip every other number now that I look at it. What do the numbers mean? Let's figure it out. What was I on last? 19. That's right. Then game 21. That's a triples game. Then game 23. Another triples game. Hope I'm coming through clearly. But then again, we seem to skip a triples game on 25 and it reappears on game 26. So it's broken the pattern. Let me see. Then 27, 28. And another triples game on 29. Triples game on game 30. And 31. Then by 32 you've won. Wow. The more you know. Oh darn. It's not coming through, but my laptop's at 8%. Where's the charger? Oh no, I can't reach. God damn it. Don't I have a portable battery pack around here somewhere? Wow. I mean, I guess that's it for now. That was a lot of math. Learned a lot of stuff. Let's take all the math we've done, shrink it down, so it doesn't take so much space. Math doesn't need to be intimidating, I suppose. But let me just take a look at all the math that I've done. So, if I took today's date and turned it into a number, that number being 1,302,024, and I found the square root of that number, if it is today's date, American style by the way, not European style, if we took that number and we found the square root of it, it would be approximately 1,101 063. That's as close as I was willing to go, at least in terms of my sanity. If I went into any more decimal places, the amount of arithmetic would be intolerable. So, the actual closest the calculator could give me is 1,141.06266260088. That mention is probably more, but that's as much as the calculator was willing to go. I guess we all have our limits. Let me see. The number given by, let me see here. Who's the commenter? Beery gave the number 80,082. A very, very good round number. A very large round number. So I figured, well, what's better than 80,082? Well, I guess squaring it. So if we squared 80,082, we came up with 6,413,126,724. Very large number. Maybe next time I'll take some 6-digit numbers. Let me see. How much battery do I have left? 7%. Wow. Well, what are you gonna do? Let me see here. What was my favorite number? I think it started with a 7. Why do I not remember this? Oh, you know where it is. It's on my resume. Where did I keep my resume? I know it's around here somewhere. Let's see here. That's not over there. No, that's definitely not it. Damn, when you need something, you can never find it, can you? Nope. Is it on my laptop? I think about it where I leave my birth certificate too. Huh. Let's see here. Is it here? Most recent. Is it in my sketches? Why would I leave my resume in my sketches? That seems like a very ill place to leave it, but everything seems to be here. Let's see here. Outfits, no. Pictures, no, that's not it. Schedule, no. New folders. Is it in here? Oh, here it is. It's a hard number to remember. But according to this, at least what I wrote down, my favorite number is 406475. Yep, that sounds about right. It's a very large 6-digit number. 406,475. This would be my favorite number of all time. Maybe I could do something with that next time. What am I at? 5%? My goodness. The last thing we did was, if you took every single person on Earth and made them play rock, paper, scissors, how many games would it take to beat everyone? Well, according to this, it would take 32 games, and you have beaten all 8 billion people. Congratulations. Well, with lack of energy, at least for my laptop, I guess that's gonna be it for now. Okay, take care.